Hi guys, welcome to my channel, and today we'll be talking about time-based OTP generation and validation, and we'll go brief into about how they actually work and what are the different types, and if you want to build one, how would you build one actually? So let's talk about it in detail. So the first part will be the foundations. So let's talk about what ways they actually work on. So you would want to understand that, hey, this is just maybe how does it work on? You would imagine that server and your mobile would be some kind of a sync, and it would be constantly sending you codes, but that's not the case, because if that would be the case, there would have been no synchronization and chance of them leaking would have been very high. So they don't work that way. I tell you what they actually work on. They actually worked on a shared secret and the current time. That's how the mobile as well as on the server, they generate the same code and then they match it. That's the basic gist about time-based OTPs. And that's all you have to remember whenever somebody asks you, hey, how does the time-based OTPs works? You never have to say that they are being generated on the server and then be sent to the client. No, it does not work like that. So let's get into it. If we talk about the function, the basic foundation, they work on shared secret. So whenever you install your authenticator app, and try to scan a code, so you might have done it in your companies, or maybe you want to set up two-factor authentication. You would scan some kind of a code, and once you scan that code, there is a shared secret between your client and your server. And once the shared secret is between the client and the server, it's just similar to like what is a public key and a private key. In that case, well, your client will be generating a code, and your server will also be generating a code, and they'll be matching it. That's it. And the algorithm behind is the RFC623 algorithm. Also, how does it work? Your your shared secret, which is some kind of a base 32 encoded string shared between your client and a server, and using your current time, it will generate a token, or let's say a time, a code, let's say 1 2 3 4 5 6. And when you send your you log in when you log in and you do a two-factor authentication and you send your code back to the server would validate the same by generating the same token, because they have a shared secret. The server will say, hey, I know the secret of this client, or I might know the secret of this client, so let's fetch the secret of that client, and using the current time, let's generate a code. And once it generates a code, it tries to match. So in that case, that's how the validation works. So if somebody asks you what's the algorithm, it's RFC6238 algorithm. And I think this has been used in mostly all of the time-based OTPs. Now coming to what are the different types in it. So I think there are two types in it. One is the stateless validation, and then one is a stateful validation. You might ask, what is a stateless and a stateful? Well, some companies or some algorithm states that if you want to use your OTP, it should be only used at once. So what some algorithm or some setups do, that they don't want your time-based OTPs to be used more than once. So once a code has been generated, it will store either in a Redis or in a memory that, hey, this was the last time this code was used in duration of that time. If that code is again repeated, it will say this is not a valid time-based OTP. That's how the statefulness is maintained. Whereas in case of statelessness, you keep the entire token or the time which is generated using the shared secret plus the current time for that entire minute or 30 seconds. That's how the stateless validation works. So it's pretty simple. You generate the time-based OTP from your client, and then you transmit it from your app or your mobile via login. Once the server retrieves it, it checks for the shared secret for your particular client, generates the same code, and matches it. Yep. Now comes the very important part, the clock drift. You might have seen that even if you submit your token after, let's say, a 1 minute or so, it still allows you your authentication, whatever it is being used for. That's called the clock drift. So to ensure a smooth experience, usually the server may be placed in some other zone, and it might take some few seconds to reach it, or due to any lag, maybe the code does not reach the server. It's possible that a delay can occur, right? Now, in order to handle that, there is usually a clock drift, and it allows up to few seconds based on how the server has implemented it. And that's why in most of the places you would face the scenario that a code still works. As we talked, stateful validation is again the same thing. Here your usage tracking is done. Whenever the time-based OTP is consumed by the server, it maintains a track that, hey, this OTP was used and it cannot be used. That adds up a security onto your time-based OTP validation. And this is actually being used by most of the companies, not just a stateless, they use a hybrid of it. So this is a small uh, differentiation of how both of them are: storage only, shared secret. Stateful, they will store your secret plus the last used step. Talk about protection. In that entirely 1 minute, your it's protected. And if we talk about stateful, your code is only used once. It's excellent protection. And well, obviously the stateful would require you to store data in a database, and you have to keep checking it, fetching it, so it's a little overhead on you. Well, yeah, as I said, most of the companies use hybrid, and that helps them stay ahead of others. And yeah, if you have any questions or anything, do reach out to me, put your questions in the comment, and let's meet in the next video. Goodbye.